On the edge of science. Exploring new AI neural networks. Abstract. Artificial intelligence. AI has made remarkable progress in recent years, and neural networks have played a pivotal role in these advancements. As AI researchers continue to push the boundaries of what is possible, new frontiers in neural network design are constantly being explored. This paper delves into the cutting-edge developments in AI neural networks, including novel architectures, learning paradigms, and applications. We discuss the key trends and challenges in the field, shedding light on the potential for these innovations to shape the future of AI. Introduction. Artificial neural networks have revolutionized the field of AI, enabling machines to perform tasks that were once thought to be the exclusive domain of human intelligence. Over the years, we have witnessed an evolution in neural network architectures and learning paradigms, from the humble beginnings of perceptrons to the emergence of deep learning and beyond. This paper explores the latest developments in AI neural networks, highlighting the promise they hold for the future of AI. Novel neural network architectures. Point 1. Transformer-based architectures. Transformer-based models, originally designed for natural language processing, have emerged as versatile architectures with applications across various domains. The introduction of the transformer architecture marked a shift from recurrent and convolutional neural networks, enabling the modeling of sequential data more efficiently. GPT-3, BERT, and their derivatives have showcased the power of large-scale transformers in tasks such as text generation, translation, and even image synthesis. 2.2. Spiking neural networks. Spiking neural networks, SNNs, have gained attention due to their biological inspiration, mimicking the behavior of neurons more closely. SNNs utilize spiking events to process information in a manner that is energy efficient and potentially more brain-like. These networks have shown promise in applications like neuromorphic computing, event-driven sensors, and even advanced robotics. Advanced Learning Paradigms 3.1. Reinforcement. Learning reinforcement. Learning RL continues to be a focal point of research, particularly in applications requiring autonomous decision-making. Recent developments in RL include the use of model-free and model-based algorithms, off-policy learning, and deep reinforcement learning, leading to significant breakthroughs in areas such as robotics, self-driving cars, and game-playing agents like AlphaGo. 3.2. Few-shot and zero-shot. Learning few-shot and zero-shot learning paradigms aim to train models on limited data or even unseen classes. Innovations in this area have the potential to reduce data dependency and enable AI systems to adapt more rapidly to new tasks. Meta-learning, transfer learning, and generative models are instrumental in advancing these paradigms. Emerging AI applications. 4.1. Healthcare. AI neural networks are making substantial contributions to healthcare, from diagnosing diseases in medical images to drug discovery and personalized treatment recommendations. Innovations in this domain have the potential to save lives and improve the quality of healthcare worldwide. 4.2. Autonomous systems. The development of AI neural networks plays a crucial role in autonomous systems such as self-driving cars, drones, and unmanned aerial vehicles. These systems rely on neural networks to perceive and navigate their environments, ensuring safe and efficient operations. 4.3. Creative arts. AI is increasingly entering the realm of creative arts, with neural networks being used to generate art, music, and literature. These AI-generated creations challenge our understanding of creativity and push the boundaries of what AI can achieve in the realm of human expression. Challenges and future directions. While the developments in AI neural networks are promising, they come with their set of challenges, including ethical concerns, model biases, interpretability, and the need for more energy-efficient architectures. Addressing these challenges is crucial for the responsible and sustainable advancement of AI. The future of AI neural networks holds exciting possibilities, from improved generalization and understanding of complex data to the creation of more human-like AI systems. As researchers continue to explore the frontiers of science, it is essential to remain vigilant, ensuring that AI is developed and deployed in ways that benefit society as a whole. Conclusion. Artificial intelligence, with its neural networks, continues to evolve, pushing the boundaries of what machines can achieve. The innovations discussed in this paper represent just a fraction of the ongoing research and development in the field. The future of AI neural networks promises to be even more transformative, offering potential solutions to some of the world's most pressing challenges and reshaping industries and society as a whole. As we stand on the edge of science, exploring these new neural networks, the possibilities seem limitless, with the potential to bridge the gap between human and machine intelligence like never before.